Okay, this is chapter 5, chapter 2, section 5. We already went over the parent functions, which the book calls power functions now. Same thing, we'll call them power functions or parent functions. And we're going to talk about the piecewise defined functions and the greatest integer function, which is also known as the step function, which is usually what I call it, because it looks like stair steps, so I call it the step function. And a lot of books call it that as well. Okay, the first problem we're going to go over is 37 in your book. This is what it looks like. So let's just look at this and see what this is, first of all. We have 3 pieces. 1, 2, 3. Hence, piecewise defined function. You should know what this looks like. You know that this one right here is your absolute value function, and you should know what that looks like. You know this one is your cubic function. You should know what that looks like. This case, this one right here, this is just a point. And so that just means when x is 0, y is 1. Okay? So we also are going to have to evaluate points. So if I ask you what is, for this whole thing, what is f of negative 1? Well, for my restrictions, the only place that I can put negative 1 is in this first one. Because negative 1, right here, is in between negative 2 and 0. So I have to use this function here, the absolute value function, to evaluate. So the absolute value of negative 1 equals 1. Now for f of 0. Okay, in this first one, it can't equal 0. But in the second one, it can. So clearly, when x is 0, y is 1. And f of 3 belongs to the third piece, because that's for all, because 3 is bigger than 0. And so I evaluate it, and that's going to be 3 cubed, which is 27. So you're going to have to do that and know your pieces. So that's just each piece, easy enough. Just make sure you look at the restriction and place the proper x where it goes, the x where it goes. Alright, now we're going to have to graph it. So the first part was this absolute value. So we're looking between negative 2 and 0. So I go back here and I'll have the absolute value. So I'm going to do absolute value of negative 2. It includes all real numbers, so negative 1. And I'm also going to include 0. Even though it can't equal it, I want to get close to it. So the absolute value of negative 2 is 2. The absolute value of negative 1 is 1. And the absolute value of 0 is 0. Now it can't equal 0. This equals 1 equals 2. So we're just going to do open circle here. So it's going to be like a hole. And I know the absolute value is not curved, that it's a straight line, so it goes just like that. So I just drew the first piece. Okay, so what happens at 0? So at 0, we know at 0, y equals what? 1. So I go back here, and at 0, y equals 1, and that's a point. So I just put a point there. That's the second piece. Now the third piece says all numbers bigger than 0, our power function is x cubed. So I'm going to start at 0 even though it doesn't equal 0. So I'm going to do 0 cubed, and it's continuous. So 0 cubed, 1 cubed, 2 cubed, and so forth. So 0 cubed is 0. That's going to be an open circle because it can't equal it. It says it can't equal it. In fact, at 0 it is 1. So that 1 cubed is 1, 2 cubed is 8, and so forth. And you should know what y equals x cubed looks like. You know, it's that odd function that looks like a a curve here. I don't want to draw it, but so at 1 we have 1. At 2 we have 8, which is way up here somewhere. So I'm just going to kind of go up there. And you know it's curvy. And it kind of goes up there because 3 cubed would be 27. And there's your function. So this part's supposed to be straight. It kind of looks curvy, but that's straight. And this is a curve. And there's a point right there. Okay? You have to state your domain. Well, let's look at this. What is our domain? You can actually get it from here as well. We're starting at what? -2, and where are we ending? Anything bigger than 0. So basically on the domain, I would say that it's all real such that x has to be bigger than or equal to what? -2. Now, what do you think about the range? Well, you can tell the range just by looking at the graph. There's no negatives. Everything's positive, but it can't equal 0. We have a hole there. So we're just going to put y is bigger than 0. Okay? What else do we have to do for this? Intercepts. Do I have any x-intercepts? So x-intercepts. Look at that in green. X-intercepts. Do you see any crossing on the x's here? No, because that's an open circle. So we have none. We do have a y-intercept. There's a point on the y, so that's our y-intercept. So our y-intercept is 0, 1. And that's how you would do a piecewise function. And we'll do more of those in class. Okay, now let's go to do the step function. And the way your book does it, they write it as, I'm going to just use y equals integer int of 2x. And I'm not going to do that on your test. I don't think I did that either. I'm going to write it this way. So if you see a bracket like this, that means the greatest integer function. Okay, so let's talk about what the greatest integer function. I suggest you look it up in the book on page 111. The greatest integer function is the greatest integer less than or equal to the x. So the greatest integer function is less than or equal to the x. So let's do a table of values real quick. So, do a table of values. I'll start with -3, -2, -1, 0, 1, 2. In this case, it's pretty easy because it's just going to be x. So the 2 times -3 is -6, -4, -2, 0, 2, and 4. Okay, but let's put in some fractions because we want continuous. So let's do another table. And I'm going to go from 0, -1/2, and actually I should have done something different. I'm going to do -3/2. No, I don't want to do that. I'll just do -1/2. Anyway, let me show you what it looks like. We'll do 2 of these because I think it'll be easier to show in a different one. This is what the greatest integer function looks like. So what we're going to do is it's going to jump. There's no fractions in between. So at 0, it's 0. And then once we go to 1, so we go to 1, it jumps up to 2. So let's say this is 1 and this is 2. So you go up to 2. And then once you get to 2, it jumps up to 4. And so forth. And it's going to keep jumping like this. And you do the same here. and it goes back. So that's what it looks like. It's a stair, looks like stair steps. That's why I call it the step function. Okay. Now I kind of want to do one that's has a fraction in it. Is there one? There should be. Let me see in the book if there's one with a fraction in it. Yeah, I want to do 28. So let's look at 28. So 28, it's x over 2. And I'm going to draw that. And the main thing I want to show you on 28 is if you have, say, y equals the greatest integer of x over 2. Alright, so it has to be the greatest integer less than or equal to x. So when I do a table, we'll do this one in class again, so don't worry so much about this one. Alright, so when I do my values, I'm going to start with 0 here. When I put a 0 in here, 0 over, this is x, then your y is going to be 0. But if I put a 1 in here, 1, that's going to be 1/2. But 1/2 is not an integer, so you move it back to 0. If you do programming, it's called the ceiling and the floor, if you've done computer programming. Now when you go to 2, 2 over 2 is 1. But when you go to 3, 3 over 2 equals 1.5. But f of 1.5 goes back to 1 because it's the greatest integer. You can't have a fraction in your range because it's the greatest integer less than or equal to x. So we can't go to 2, but we go back down to 1. When we do 4, we're going to do 2. We go to 5, we're going to go back still to 2. Do you see the pattern? So when you draw this, you're going from 0, let's say 0 to 1 is 0. So this is 1. Alright? And this is 2 here. So once you get to 2, it's not 0 anymore. This is 1. It goes to 1. And it's going to continue to go like this. This is kind of hard to do a video on the more I do this, so we'll go over it in class. And talk more about the greatest integer function. The main thing I want to look at on these, though, is the domain and range. Now, the domain can be anything. So the domain, we're just going to say x such that x belongs to all real numbers. But the range is y belongs to the integers. So this is kind of like a mapping from the reals to the integers. You cannot have any fractions here, but you can here. Okay? Go ahead and look at the book, see if you can work some of these out. We will talk more about this. That's why we went ahead and did the parent functions or the power functions early, so we can concentrate more on this. And that's all.